Episode 130 of CppCast with guest Dr. Greg Law, recorded December 13th, 2017. This episode of CppCast is sponsored by Undo. Debugging C++ is hard, which is why Undo's technology is proven to reduce debugging time by up to 2/3. Memory corruptions, resource leaks, race conditions, and logic errors can now be fixed quickly and easily. So visit undo.io to find out how its next-generation debugging technology can help you find and fix your bugs in minutes, not weeks. And by Audible. Get a free audiobook download and a 30-day free trial at audibletrial.com/cppcast. Over 180,000 titles to choose from for your iPhone, Android, Kindle, or MP3 player. In this episode, we talk about deprecating features from C++. Then we talk to Dr. Greg Law from Undo. Greg talks to us about how reverse debugging is becoming a thing. Welcome to episode 130 of CppCast, the only podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
Doing okay. How are you doing, Rob?
I'm doing all right. Your tooth going to be okay?
Yeah, you know.
Well, I'll tell
for our audience, yeah. I popped a crown off this morning, so I'm just waiting to go to the dentist to get it glued back on now.
Well, hopefully it'll be okay for the next hour.
It'll be fine. Yeah.
Well, at the top of every episode, I'd like to read a piece of feedback. And this week, Jason, we got a tweet between you and then Bartolomej Flipik. I apologize if I butchered that name. But apparently you got some of your episodes of C++ Weekly transcribed?
Yeah, the last 2 episodes to go live, someone has done a community transcription of it within 24 hours.
Oh, wow.
I'm not sure who it is, and I'm not even sure how to see who it is on YouTube. I don't know what I'm missing there. But I just did a quick review of it and approved it. So, yeah, and then there's a couple of older ones that also have transcriptions.
And that's something just built in within the YouTube platform? Someone can volunteer to transcribe someone else's video?
Yes. And there was actually talk from last year at CppCon about doing this and why it's important to support this community effort for conference talks.
Right.
Because if you're a non-native English speaker, understanding someone's spoken English can be difficult. Being able to read it is that much more helpful. And on the off chance that someone else can then translate the English into another language, that opens it up to that many more people.
And obviously there can be deaf programmers who would want to see that content as well. Yeah.
That also, yes, of course.
Yeah. So Bartolomej was asking, are there any plans to transcript CppCast episodes, saying it would also be handy if at least mark main points from the interview and time when they happen. I think I looked into transcription services, and it is quite expensive. So I don't think it's really something we could do anytime soon, but the idea of at least marking points in the conversation, I thought maybe we could do. Just say like, hey, we started talking about news here, we started talking about this topic, transition to that topic. I feel like we could probably at least do that.
Yeah, it's also, from the YouTube standpoint, the automated Google text-to-speech thing gives you a kickstart to it. Right. And it's hypothetically possible that we could upload some of these to YouTube as just audio tracks and let it do the transcription for us.
That's true. We could also possibly record, but I don't know if anyone needs to be seeing us while we're doing this.
No. No.
Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes. Joining us again today is Greg Law. Dr. Greg Law is co-founder and CEO at Undo. He spent nearly 20 years writing systems-level code, including novel kernel designs and networking architecture in academia, and at a variety of startups. Greg finds it particularly rewarding to turn innovative software technology into real business development. He still gets to write some code, although sadly most of his coding these days is done on airplanes. Greg lives in Cambridge, England, with his wife and 2 children. Greg, welcome back to the show.
Hey, hi, thank you, yeah.
How's the weather in Cambridge this time of year?
It is, today is very grey and drizzly and really not very cool, but last weekend we had some snow, and that was the first snow, like that's really the first snow we've had in Cambridge, I think for 4 years, like proper snow when you can make a snowman, right?
Wow.
So the kids were out enjoying the snow. I mean, they were beside themselves. We have a dog who's like less than 2 years old, so that was the first time he'd seen snow. He had no idea what to make of it. So that was good fun. But now it's like there's just, you get those snowman corpses in the park, and then it's all kind of back to normal apart from that.
That makes it's a very interesting weather year then, I guess, because here in Denver we've had virtually no snow, which is weird. We should have had, more than one snowfall by now. And I have family in Atlanta, which they had like 4 inches and were making snowmen and snow forts and stuff, which is highly unusual for them. Did you get hit by that snowstorm also, Rob?
Yeah, I was just going to say, I know Atlanta had that snow. We did not really get hit by it. We got a little bit of slush, but that's about it. Although my kids, they grew up in New Jersey and now we live down in North Carolina. So they're quickly forgetting what snow really looks like. When Atlanta was getting the 4 inches, we just had some frost the next morning, and my daughter was asking if she could go out and play in the snow. And I'm like, no, honey, that's just some frost on the grass.
It's not how it works.
Yeah.
No. Make a frost man. It would take a lot of effort. A lot of effort.
Yeah. Well, Greg, we've got a couple news articles to discuss. Feel free to comment on any of these, and then we'll start talking to you about what you've been up to with Undo, okay?
Yeah, awesome.
Okay, so this first one is actually just the start of what looks like it's going to be a multi-part blog post from Jeff Amstutz, who was on the show a while back, and this is about building a C++ SIMD abstraction, and it relates to the work that he's doing on Osprey.
Yeah, there's a lot of information in here. I didn't have the time to really dig into it yet, but I had also recently been playing with when the compiler can generate SIMD optimizations for you.
Yeah, and like I said, this is kind of like an intro to what looks like it's going to be a series of posts, so maybe we can talk more about it as he continues along with the series. But this first one is kind of just like an intro to the SIMD concepts, and it's definitely worth reading.
Right.
Yeah. Next up, from the Visual C++ blog, we have a nice long post from STL talking about feature removals and deprecations, and basically just talking about, now that we're getting into C++ 17 and they've introduced the stood C++ 17 flag or stood C++ latest, what you can expect to see deprecated and eventually just removed entirely from the Visual C++ compiler.
This is great.
Yeah.
We like
removing stuff is great. It's almost as great as getting new stuff.
Yes. That in some ways better.
Possibly.
I just wish we could deprecate standard bind, which will never happen, probably. But with C++ 14 and lambdas, it's virtually useless.
Yeah.
So I guess they have a good sense on which features are very rarely used so they can remove it without causing too much carnage, right?
Generally speaking, they're features that either were never really used or features that were actually problems.
Right.
Like auto pointer. Auto pointer's never been possible to use correctly, basically.
Right, but even... Go ahead.
What's that?
I was just going to say, even if you rely on some of these older features that are going to be deprecated, you could still compile as like stood C++ 14, is my understanding.
Yes.
Yeah.
And there's flags for many of them, preprocessor defs and stuff that would let you turn them back on if you really wanted to.
Right.
Yeah, you can restore auto pointer by defining has auto pointer, etc. to 1. Don't do that.
Right. Okay, and then the next post is on Simon Brand's blog, and it's a kind of a follow-up to one we were talking about last week, where we were going back and forth between exceptions and error handlings, and what should be the best practice. And I found this post to be pretty interesting, especially one thing he mentioned in the beginning, where he talked about how we shouldn't just use one or the other based on what he referred to as cargo cult software engineering, which is a term that I probably have heard before, but haven't read the genesis of. Jason, were you familiar with this term?
Of cargo cult?
Yeah.
Yes. Yeah. I am reluctant to describe it fully here because I don't know if I'd get the details right, but yeah, it stems from World War II.
World War II, setting up military bases on these islands, and then Aboriginal people imitated the people trying to land airplanes and such after the bases were closed. I thought it was pretty interesting.
Yeah, so some of the people left behind have done things like make bamboo airplanes,
right,
and an airfield left and stuff. Yeah.
Yeah,
I heard of cargo cult for the first time a week ago at a conference in London, DevRelCon, and now here I am hearing about it the second time. So I guess it's becoming a meme.
Maybe.
Yeah, it's been many years since I first heard it, but I haven't heard it very often.
Yeah, and basically the point of it is, don't just follow what's, maybe good advice without fully understanding the reasoning behind it. Like if you're programming something and you are told this is a best practice, you should kind of understand why it's a best practice and not just imitate it blindly.
Or even worse, just doing something because you see other people doing it without even knowing why they did it.
Exactly.
Or if they even pretended it was a best practice.
Right. And that's what this post is all about. He thinks, before we make too many, decisions on the types of error handling or exceptions we should use, we should kind of understand it better. And he's kind of making a call for people to, try to gather some data about it.
Yeah.
Okay. Well, Greg, it's been about 2 years since we first had you on the show. Could we start off by just refreshing our listeners about what Undo DB and Live Recorder are, and maybe if there's anything new product or feature-wise that's come out over the last 2 years, you could mention those?
Yeah. First of all, I can't believe it's been 2 years. I would, if you'd asked me to guess, I would have said earlier, beginning of this year or something. But anyway, yeah, I guess time flies when you're having fun. Yeah. So just to remind us, Live Recorder and Undo DB both are products that allow developers of C++ code on Linux to record the execution of their program and then wind that tape back and forward. And so the viewer onto your recording is a debugger, typically GDB. And then, you can kind of wind the tape back and step back. You can step back to any line of code that executed, and you can see full program state for any point in history, right? So it really, it allows immediate and clear answering of the how did that happen question that we're all familiar with, as programmers, right? Never works first time. And, more often than not, we're kind of scratching our heads trying to figure out why reality kind of diverged from our expectations and, where reality diverged from our expectations. So having the tape that you can just kind of wind back and see precisely what happened is, a really powerful way to answer those very difficult questions. So people often sometimes people see this and the first thing they think of is just, that extreme frustration when you're stepping through in the debugger and, you accidentally step over one too many function calls and it's I've gone too far. And so their immediate thought is, oh, right, great. So I can back up and remove that frustration. And, that's certainly true. But really that's just the tiny piece of the advantage of this. The advantage of this is to be able to know what the computer really did, right? To know what the previous states of your program were and be able to kind of navigate through history back and forth. So just kind of unpicking stepping too far is just, that's 1% of the overall value. Going back, and so you can, if you've got memory corruption, if you've got race conditions, if you've got stuff like that, and these kind of stateful errors where the problem itself is a long time before when you notice, then, no longer having to guess how you got here, but just go back and see what that was is very powerful.
So what is the granularity of this recording?
So this is it's everything, right? I mean, there's nothing about the program's execution at the logical level that you cannot know. So
it's not like every CPU instruction or something.
Oh yeah,
like
no,
that.
every CPU instruction. Now, so when I say the logical level, so like maybe there's like cache line misses, inside the silicon, and that's, you don't see that. But you can see absolutely, you can step forward, step backwards, instruction by instruction, see, any address in memory, any instruction that executed.
Wow.
So it's full visibility. I mean, if anybody's familiar with RR, it's very similar concept to that. And likewise, a few other things that have been announced since we last spoke. So I think, in terms of, I think the big thing that's changed over the last couple of years is how, this is starting to become a thing, right? So product-wise, we've been focused very much on, robustness and performance, which are the two big things, right? So can you give this to, arbitrary, really complex code, and have it handle that and not fall over, and also do it at with good performance. So that's been, really the main progress. We have divided Live Recorder into two products. So just very briefly, UndoDB is basically an interactive debugger. It works just like GDB, right. Except you can go backwards and forwards. In fact, just in the way that you can with GDB now, go backwards and forwards, but the performance characteristics are totally different. And then Live Recorder is this kind of allows you to do this offline debug. So you record the execution of the program and then, come back and debug that the next day or a week later or whatever it is. And you can debug on the original machine where the recording was made, or you can debug on another machine. And we've kind of divided that out into Live Recorder for test and Live Recorder for production. So Live Recorder for test is aimed at plugging into continuous integration and other automated test environments where, the kind of premise is, so you plug it into your Jenkins or whatever it is that you're using. And when you have a failed test, you get instead of just having, maybe some log files and perhaps if you're lucky, a core file with the artifacts, what you get is a recording file, which gives you, full visibility into what that test did. And so particularly for intermittent, test failures or tests that fail in different ways each time, that's obviously very, very valuable. And then there's a Live Recorder for production, which is really aimed at software vendors to kind of plumb that, link that directly into their product and then ship that, or deploy that and have the ability to, then have the program record itself basically. So it's kind of packaging and positioning are the things that have changed and the use cases, I guess.
So what are the performance and disk space implications of turning on the Live Recorder?
Yeah, right. Which is exactly the right question, because making this stuff work isn't that hard. In fact, there's research papers on this going back to the 1970s where people have done a kind of prototypes and something for kind of toy languages and toy programs. So having it work on Hello World's not too bad, and you can. But if you think about what you need for this, you can have this full visibility. Every time a CPU executes an instruction, it's destroying information, right? Some information no longer exists in the universe. So at a minimum, the program counter is changing or some other register is changing. If executing an instruction doesn't change any state, then you're by definition in an infinite loop, right? Because the next instruction is bound to do the same thing. So some piece of state, at least a word, possibly several, is changing every time, every instruction that executes. just to make the math really simple, it's a gigahertz machine. It's issuing 1 billion instructions every second. That's a huge amount of, even if you're just storing the deltas between the instructions that execute, it's a huge amount of storage. It's gigabytes per second. And the performance characteristics are going to be pretty awful as well if you do that. Just the amount of time it will take to store that information as you change it. So instead, what we do is this technique that we pioneered of replaying the program execution. So if you've been running for 10 seconds and you want to go back 1 second, well, rather than try to go back, we just go back to 0 times 0 and play forward 9 seconds, right? And then there's some snapshotting stuff along the way to avoid needing to go right back to the beginning. And so that gives completely different performance characteristics than you might expect. So it means that space-wise, it depends very much on what the program is doing. If you're reading, it's basically the inputs your program is taking. So, because what you have to do to make this work is capture the non-deterministic stimuli as they come in, right? So, if your program is reading, 10 gigabit data stream, then this is going to be, the recording is going to be, of the order of 10 gigabits per second. But most programs are nothing like that I/O heavy. Actually, it's the I that counts, not the I/O. So, much more typical is of the order of, say, like a megabyte per second or something like that is kind of typical. And speed wise, again, varies a lot depending on what the program is doing. But, again, running at half speed, is kind of where is again typical.
Okay.
And running at half speed isn't that bad for something that you just turn on in order to get a log file you can solve the bug with.
Right. Absolutely. Yeah. So, you only got to, so if you, in the context of, in the context of your, CI or other test environment, that's, really it needn't be an issue at all, especially as you can turn it on just for, you turn it on just for those intermittently flaky failing tests, or you run, some of our customers, run they run 2 lots of their tests. If they're running this continuous integration, they just run it twice, once without recording, once with recording. If they can capture some of those failures, then, then they're happy. So they have those sort of running in parallel. And yeah, even for your desktop day-to-day, debugging, if you save, if it's running at half speed and you save 1 restart, then you win, right?
Right. So I've noticed that if you have a debug build that's, simply just faster than a release build because less optimizations are enabled and the binaries are bigger. But I've noticed in my own experience that if I'm running a debug build inside the debugger and the debugger is actually tracing the program execution, that tends to be slower again, but I've never actually measured that. Mm-hmm. And I'm just curious if you have any idea how much slower a regular debugger is versus, what you're doing with a little bit of the tracing and rollback ability.
Yeah, like all of these things, it's the same kind of politician's answer of, that depends.
Right.
But no, there certainly are times when, the debugger performance can be pretty impactful, particularly, for example, there's things like loading a shared library. So if your program loads a DLL or a shared library, then, typically that will trap back to the debugger. And the debugger will have to do a whole bunch of work to kind of parse that library and figure out and especially if it's some maybe it's got a load of debug info with all kinds of C++ templates and other stuff that can expand pretty quite a lot. And so that can really impact performance. So certainly loading a shared library can be orders of magnitude slower inside the debugger. Once you're up and running, and this is all really about Linux. I'm not familiar with doing this on Windows, but I'd imagine it's the same. And once you're up and running inside a debugger, if you're not hitting internal breakpoints and the like, then it's likely to go. You would expect it to go with at full speed with kind of zero slowdown, compared to if there is no debugger attached.
Okay.
It's when so for stuff like, when a shared library is loaded, it'll hit what the debugger will do is set a breakpoint inside the loader. So every time that hits, then there's a breakpoint. And every time you hit a breakpoint or something, that can be very slow, right? That can be the equivalent of millions of instructions, by the time it's trapped down to the kernel, controls come back up, the debugger's been scheduled, it's done whatever it's going to do, it then goes back into the kernel, continues the program being debugged. If you're doing that once a second, it's fine. If you're in some tight loop doing that all the time, then that will hurt you.
Okay.
I want to ask more about the live recorder for test. What does it take to integrate that into your CI? Is it a pretty straightforward process?
Yeah, I mean, we always designed this with the clear goal that it needs to be as simple as possible, right? So it's always been, you don't need to, build in any special way, link against any special libraries, whatever. So we actually have two forms of the recording, two ways to kind of integrate that. So one is a library that you can just link against, and then that has an API, and you can start recording and stop recording and save the recording to a file and do other things where you're configuring the size of logs and all that kind of stuff. And then the other model is a kind of external recording tool, and then that works more like strace or even RR, and then allows you to record your program kind of completely from the outside without needing to make any code changes at all. And so they have different trade-offs, right? About which one is going to be more convenient for you, whether you want the flexibility of the API or whether you just want to, not change your unit tests at all. And so you can kind of pick and choose. And then it just goes as a pipeline stage, in your Jenkins or whatever, right? So, getting it set up is, it's really not a complicated thing at all.
Okay, so if you're not using the library integration, it's as simple as, start live recorder and then run all my unit tests and then finish live recorder, that type of thing?
Yeah, indeed. So so it's like literally in the simplest case, it's literally just, prepending your, if you're just going to, say your test is an executable that you're just going to, run that, and it's just, prefixing live record and then the test invocation, right? So it's just like running strace.
Okay.
And then obviously that gives you different trade-offs with, then you have to record the whole test, which you may or may not want to do. And then you kind of want to configure about, whether you're going to save that recording or throw it away. And there are kind of options you can do to control that to make it a little bit easier. But yeah, always this has been designed, it was always a really important design requirement for us that, that you need this just to be as easy as you can to get going. Because we just knew that every extra hoop that the developer, or the DevOps person or whoever it is needs to jump through, then you're like, you're going to turn away half your potential audience or worse.
So as you mentioned, over the past few years, it seems that reverse debugging has become more of a thing. What are some of the changes you've seen in the industry that make you feel that way?
Yeah, I mean, so as well as projects and products coming along, which I think we mentioned the main ones of RR, and also the time travel debugging from Microsoft, which was announced by them at CppCon this year. And there's other stuff as well. So those are the kind of C++ ones, but there's other, the PyPy project has some reversible debugging built into it now. Although that's still experimental, I think, but it's there. Actually Microsoft, have, time travel debugging for JavaScript through their Chakra core engine. Oh, wow. So there's it's happening in happening in a number of places, and I apologize to anybody if I've forgotten to mention you, but I think those are the kind of main ones. And of course inside GDB as well, although that implementation is, it's so slow. I think that actually hurt in some ways, because so the inbuilt GDB implementation of this stuff, process record, works by single stepping the program and recording the changes every instruction that executes, which has the benefit of simplicity and works works pretty well when it works. It's just that it's so slow and also generates so much data. So what it means is you're kind of limited to, if there's a piece of a bug right here, you can kind of turn on the recording for that bit, and as long as it's just a sort of million instructions or so, then you're fine. I think it's also used a bit if you're just trying to explore some code. If you've got some really clever, in inverted commas, piece of C++ code that's doing something that you just can't figure out like what it's doing, then that can be useful. But that's quite kind of limited, and I think. While it was really just us and GDB, that was actually problematic for us. A lot of people would try GDB and say, you see, I knew it'd be too good to be true. I knew this was too good to be true. And, kind of immediately there was so it made a sort of credibility problem. I think now that you're seeing, these other things coming along, which are a bit more using some of the same techniques that we use, and so essentially much more scalable. People realize, this is real. This can really work, it's becoming a bit more of kind of an accepted thing, and we certainly come across it, more and more. It's still, though, to be honest, it still surprises me how niche it still is, right? So, despite, so there's, obviously there's our offering, there's open source stuff available on Linux, there's the stuff from Microsoft inside, fair enough, that's quite new, but still it's, it's there. And still, I don't know, it kind of feels like somewhere between 1 in 10 and 1 in 100 people that I speak to have certainly that few have tried it, maybe even heard of it as a concept, which still surprises me because it just is such a powerful thing and changes. It has such an impact. Like I'm sure you and a lot of your listeners will have heard the nice pithy quote from I think it's from Brian Kernighan that debugging is twice as hard as writing the code in the first place. So if you write the code as clever as you can, how will you be smart enough to debug it?
Right.
Which is a very useful piece of advice for especially for kind of programmers kind of early on in their career who are trying to, get a bit too clever, as it were, which I think we've all been through that phase. But it's interesting because if you think about what that means, the implications of that statement, it's like, well, so that means then you can only write the code that you can debug. So debuggability becomes the limiting factor on the code that you can write, right? It's a limiting factor. Whatever your metric for good is, whether it's fast, whether it's extensible, whether it's portable, whether it's, whatever, the limit of that, the limiting factor of that is how debuggable it is. So it's always amazed me that, debugging in general, I think, gets such little attention as it does, and and particularly particularly the reversible debugging still kind of remains, just not that well known. And I think it's changing, and it's certainly very different than it was, 4 or 5 years ago, and I think that change will continue, and I fully expect over the next, I don't know, 2 to 5 years, let's say, I think it will become just kind of, accepted normal practice. And like any environment that doesn't allow you to do that will be, painful. But yeah, you were still, not even anything like halfway through that transition.
It reminds me of, some of the topics that Kate Gregory has talked about, where she has been saying to not even necessarily teach your students printf or cout or whatever straight away to look at the output of something. Instead, teach them in the debugger to put a breakpoint there and look at the state of that variable and start right out from the beginning, understanding how these tools work.
Yeah, absolutely. And I know there's the school of thought that debuggers are, can make programmers lazy, if you like, and but I don't subscribe to that.
No.
I mean, I guess obviously, but I think it reminds me of there's a view that allowing students to use calculators when they're is kind of cheating, right? And there's good research out there that shows that actually if you allow kids to use calculators, their mental arithmetic gets better because they just do more math and they're just practicing this. They're just becoming part of it, and it helps them. It takes the kind of the chore away from maths, right, and makes it more enjoyable. So it's this kind of, I don't know, what's the word? Sort of masochistic kind of real men don't use debuggers, right? And it's sort of, we're going to go through the pain to, it just doesn't, I just think that's daft, right? If you've got these tools and debuggers and, could be static analysis and dynamic analysis with Valgrind and whatever it is, we have these tools like, programming's hard enough as it is. Like we don't need, like some kind of, monastic, self-inflicted pain to make it worse.
Yeah, I definitely agree. So we mentioned Microsoft's announcement of their time travel debugging toolkit. Obviously, that one's Windows only, and this is and Undo is Linux only. Do you see many comparisons between the two, though, or are you picking up any ideas from what they did?
Yeah, it's definitely interesting stuff. It's a different technique than we use. So what they're doing, although they don't, I'm just actually, as far as I know, none of this is published particularly, but I'm interpreting from the outside. It looks like what they're doing is, they are using dynamic sort of JIT instrumentation in a similar way that we do. But all that we record, as I mentioned at the beginning, all that we record is the non-deterministic inputs that come in, right? So essentially we, sort of exploiting the natural determinism of computers. So if you run a program multiple times and every time you give it the same starting state and as you run it, you feed it the same inputs, then it will always do the same thing, right? This is why random numbers are difficult to generate. And so we exploit that. And so we, when we're recording, all we record is the non-deterministic inputs, which is mostly system calls, but there's also, thread switches and signals and shared memory and some CPU instructions as well. But and then we replay those, precisely when at the appropriate time during replay and guarantee that the program follows exactly the same path, as it did in record. The Microsoft implementation is, I think, a bit different. I think what they're doing is to instrument the code, but to record all of the memory reads. So every time it reads from memory into the CPU, you log what was read. I suspect they're doing something a little bit clever and only storing what was read if it's different from what was accessed last time. I think that's essentially what they're doing, which gives different characteristics in terms of performance. So significantly more data hungry, if you like. That the log files get a lot bigger. So the log files kind of grow of, I think, if I remember rightly, they're saying it's a bit per nanosecond of execution, which I think roughly equates with that approach. And the slowdowns is a little bit worse. Does have the advantage though, is you can record genuinely multiple cores at the same time, which is pretty neat. And I must say also they've done a great job in the stuff they've built on top, which is kind of interesting. So you can query using sort of SQL type language. You can query the recording and find what the rather than sort of stepping through in the debugger, you can write some SQL and find I don't know, show me how this particular variable changed state during the execution of the program. So that's kind of neat. And I think they've used it a lot internally, right? So although saying this is actually it's sort of announced as a new thing, it's been used internally to Microsoft for many years. And I think at the announcement in CppCon, they said that over 50% now of internal Microsoft bug reports come attached with recording a trace file, as they call it, as opposed to like, some instructions of, do this, do that, do the other, and then it died. So I guess, inside Microsoft, it's not a niche thing at all. It's already made that transition. So, very exciting to see how that spreads, to, the rest of the world.
Yeah. So based on what you said earlier about how many developers you run into who are aware of, reverse debugging, it seems like it must be exciting for you just in general to see that it's getting more and more awareness.
Yeah, absolutely. And I think for quite a long time, I did feel a little bit like a lone voice in the wilderness.
Right.
And this is, because I started, tinkering with this stuff back in 2005. We weren't really a business for quite a long time. It was like a project, evenings and weekends project with me and Julian Smith, my co-founder, before we kind of made it a proper company in 2012. And I kind of quit the day job and started working out of the shed in my garden full time. But, in the intervening 7 years from, I remember just thinking, I had a conversation with, it's kind of, I don't know what you'd call it, like a business advisor type person back in the sort of early days. Says, yeah, I'm going to build this thing and it's going to be totally awesome and everyone's going to want it. And I remember him saying to me, well, but what have you thought about marketing? How are you going to get the word out there? I said, oh, no, it's fine. It'll just go viral. Like, this is so powerful. Everybody will just, and he's, well, everyone kind of says that. So, yeah, but we're different. It's, yeah, everyone thinks they're different. So, yeah, I'm sure everyone does think they're different, but like, this really is different. Right? And I remember even, this is a bit embarrassing, but when we put the thing, we announced it, we put it up on the website and said, here it is, come download a trial and all that stuff. And I actually warned our web hosting provider that we were going to go live and like there could be, a big load on the server. And they said, yeah, okay, it's fine. I think we've got this. And I'm not sure what I expected them to do, but I just sort of felt I should warn them. And of course, absolutely nothing happened, right? It's just tumbleweeds. And so there was some, I admit there was some dark moments in, when I'd been plugging away, Jules and I had been plugging away at it for 5-6 years. And, you're just thinking, wow, no one's paying attention to us. Am I just deluded? Is this just really not actually that useful after all? So yeah, it's very gratifying now to see that, I wasn't mad. I was just impatient.
Right.
That kind of transitions into my next question. At CppCon this year, you actually talked more about the business aspect of Undo and your process going through that. Unfortunately, that talk wasn't recorded as far as I can tell. Do you want to tell us a little bit more about it?
Yeah, right. It was a lunchtime talk. So not recorded. It was, fair enough because it's a C++ conference and clearly the talk wasn't really about C++. So it was one of the kind of open sessions, but it was very well attended. I was very pleased with, how many people actually came to see it.
Do you want to tell us a little bit more about the topics you discussed in that talk?
Yeah. So, the main part being, I think it's, a lot of software developers are kind of thinking along the lines of, well, maybe, it's an attractive thing to go, to go and do a startup, see if you can, and whether it's you want to start a business so that you can, get the income to write the code that you want, or whether you want to, write some code so that you can make the business you want. It's a common thing to do. So basically my talk was saying to everybody, for God's sake, don't do it. No, I'm just kidding. But it was, but there was a lot of surprises, right? So I mentioned one earlier about, how difficult marketing is and how hard it is to get noticed. And, And there are a whole number of surprises, things I thought I knew or didn't even know I didn't know. And, so stuff around, funding. And I think, a lot of it was also around the kind of, not just about if you're going to do a startup, but the kind of commercial aspects of, like even if we just, you have most software developers need to interact with commercials in some way or another, right? They need to talk to the sales people inside the company they work at, or, because ultimately, who wants to write software that nobody uses, right? So, or if it's an open source project that you're just looking to get users, you still have, so there is this kind of, for software to become useful, you have the kind of, you've got to write the software, but just to kind of, build it and they will come. Well, it's not like that. For programmers, the kind of the commercial side of it is often very counterintuitive and just hard to understand. So, it's the classic thing that the engineers, are like, oh, those sales guys they're all kind of stupid and aggressive, and why do they keep going off doing all these stupid things? And I've worked in different size companies over the years as a software developer, and certainly have felt that myself. And then it's got a realization that actually the thing is with sales is that you have to persuade other people to do what you want them to do. And that's way harder than persuading the computer to do what you want it to do. And then with marketing, it's even worse because you have to persuade these people to do something, and you haven't even met them. You don't even get to talk to them, and yet you have to persuade them to do what you want them to do. I remember when I was an engineer in other startups, and I'd be the engineer that the sales guys would like, because they could kind of wheel me out to customers, and I could do the PowerPoint presentation and do the demo, and not kind of fall to pieces or whatever. And I remember, I'd think, I don't think in a particularly bitter way, but I'd kind of think, I did all the work there, right? Sales guy, brought me in, shook hands with a few people, introduced me. I presented some slides that I'd written. I did a demo that I'd produced. I answered all the questions and, struck up the rapport with the people in the room. And then at the end, the sales guy, shook hands and left. And then, a few months later, the purchase comes in, and the sales guy gets all the credit. Of course, I had absolutely no idea how much work had gone on to getting me in the room in the first place. And then how much there was after that to actually turning a delighted response, people saying, yeah, this is awesome, we really like it, and definitely, want to have further conversations and stuff. Turning that into a sale where money changes hands is really hard. Just so many things can go wrong, and getting that sense of momentum and excitement to continue once the people go back to their desk and they check their emails and they have 4 urgent emails in their inbox. And, it's just this whole other world that I think as software developers, we're often exposed just slightly to, but we don't really see it. And I think, that hopefully that can help, I think, by understanding the people on the sales and marketing side inside the organizations that we work for better. Hopefully we can all work a bit better and maybe, enjoy our work a bit more.
Yeah, definitely. So where would people go if they want to go and try out Undo and Live Recorder and everything?
Yeah, so you just go to undo.io, a couple of clicks through that I think are hopefully fairly well signposted, and you can get an evaluation and just try it out. I'd love to, and love always really encourage feedback from people who've tried it as well. So whether that's, good or bad, or even a bit pernickety, actually, nothing's too pedantic. I think often people kind of don't want to give feedback because they think, yeah, well, that kind of doesn't really matter. But you know what? If you think it could be a bit better than in this way or that way, then, please do let us know.
Cool. Okay. Thank you so much for your time today, Greg.
Okay, yeah, thanks, guys. It's a pleasure.
Thanks for joining us.
Thanks so much for listening in as we chat about C++. I'd love to hear what you think of the podcast. Please let me know if we're discussing the stuff you're interested in. Or if you have a suggestion for a topic, I'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. I'd also appreciate if you like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at LeftKiss on Twitter. And of course, you can find all that info and the show notes on the podcast website at CppCast.com. Theme music for this episode is provided by podcastthemes.com. Website at CppCast.com. Theme music for this episode is provided by podcastthemes.com.